handling. In this session, you will learn to identify the various types of classes, identify relationships between classes, and identify interfaces. Once you identify the classes from the problem statement or use cases, you can classify classes into various types. This enables you to make the software system reusable and manageable. You can classify classes into abstract class, parameterized class, factory class, and self-linked class. Let's start to learn each of the preceding class one by one. An abstract class is used to define the common features and common behavior of a set of subclasses. Such classes do not have any direct instance. However, the classes inherited from an abstract class can have direct instances. The figure displayed on the screen shows the UML notation for an abstract class. The UML notation of an abstract class is similar to the class diagram, but the name of the class is italicized to indicate that the class is an abstract class. The second type of class is the parameterized class. A parameterized class, also known as a template class, enables you to use operations and classes to work with different data types. A parameterized class consists of type parameters that are unbounded. This means that the data types of the parameters are not defined in the parameterized class. Therefore, you cannot create objects of a parameterized class. To use the functions defined in a parameterized class, you need to realize a parameterized class by using other classes. The data types of type parameters are defined in the classes that realize the parameterized class. As shown in the figure, the list parameterized class is represented by a dashed rectangle placed on the upper right corner of the class. The dashed rectangle contains the formal parameter of the type T, and the add function is using the type T. For more details, refer to your courseware. The next type is the factory class. A factory class is a class that has multiple objects with the same attribute values. To represent multiple objects of a factory class, you can use the symbol of overlapping rectangles. The figure on the screen shows the factory class representation in UML. For more details about factory classes, you can refer to your courseware. A class that has objects which fulfill more than one role is called a self-linked class. A self-linked class is used to represent an instance that holds more than one value. For example, in an organization, if the employee, Stevens, acts as both a project manager and a team leader, then the two positions are linked. In this scenario, the instances of Stevens in the employee class are linked, as shown in the figure. There are various types of relationships that exist between classes, which are association, generalization, dependency, realization, recursive aggregation, and qualified association. You have already learned about association, generalization, dependency, and realization in one of the previous sessions. Now, in this session, you will learn about recursive aggregation and qualified association. Recursive aggregation is an association relationship between two objects of the same class. This relationship exists when two objects of the same class have an association relationship. For example, consider the project manager and developer objects of the employee class. The developer reports to the project manager. Therefore, the project manager and developer objects share a recursive aggregation relationship, as shown in the figure. For more details, refer to your courseware. Next is the qualified association. The qualified association is an association relationship that relates an object of a class to a particular object, or a set of objects of another class. You can use a value or an attribute of the class, to distinguish the objects of one class from another. For example, many students are associated to a university. To distinguish a particular student from other students, you need to map a particular enrollment number to the student. For this reason, the university class uses the enrollment number attribute of the student class as the qualifier to distinguish a particular student from other students. The university and student classes share an association relationship, as shown in the figure. An interface is a collection of operations that is used to represent the services provided by a class or component. An interface provides the declaration of only the public methods, and does not provide their implementation. As a result, interfaces do not contain attributes. Like classes, interfaces are also contained in a package. However, you cannot instantiate interfaces. To create an interface, you need to identify the methods that are interdependent, and group them. Let's start how to represent an interface in UML. UML provides two types of notation to represent an interface, which are the circle notation and the class notation. In the circle notation, each interface has a unique name that is prefixed with the name of the package in which it is contained. As shown in the figure, storage represents the package name, and ifile represents the interface name. The next notation is the class notation. In this notation, an interface looks similar to a class diagram, but in the first compartment, the tag named interface is required to indicate that it is an interface diagram, and the methods are declared only. After creating an interface diagram, you may need to design a diagram for interface realization using classes. The realization of an interface means implementing the interface in a class. The class must provide the implementation of all the methods that are declared in the interface. UML provides two types of notation to represent the realization of an interface, which are the lollipop notation and the dashed arrow notation. The lollipop notation shows the interface as a circle, and displays the class that realizes the interface in a rectangle. The details of the operations contained in the interface or class are not shown. The displayed figure shows how the accept credit card class realizes the interface I accept card. On the other hand, the dashed arrow notation shows an interface using a class notation of UML and dashed arrows, which connect the classes that realize the interface. The dashed arrow notation shows an interface diagram as a class diagram, with the help of the interface keyword. The diagram also specifies the operations of the interfaces. A dashed arrow connects the class that realizes the interface with its method implementation. The displayed figure shows how the accept credit card and accept credit card classes use the dashed arrow notation to realize the interface I accept card. In this session, you learned that an abstract class is a class that does not have any direct instance. A parameterized class, also called a template class, provides a mechanism that enables you to use operations and classes to work with different data types. A class that has multiple objects having the same attribute values is known as a factory class. A class that has objects which fulfill more than one role is called a self-linked class. An interface is defined as a collection of operations that specifies a particular service of a class or component. Happy learning!